Welcome back to our how-to series on the Climatiq Excel add-in. In this video, we'll look at how you can reduce the number of hours you're spending on matching emission factors to your business data using our Autopilot feature within Excel. We understand that scouring through multiple emission factor databases online and trying to match thousands of lines of your procurement or material data to the correct factors is a tedious and time-intensive approach. Manual mapping and makeshift databases of possible emission factor matches aren't going to live up to the auditor's standards. That's why we built a solution to directly address the stresses of data mapping. We developed a machine learning model, the Autopilot, to handle the heavy lifting for you. The Autopilot instantly matches your business data to the best fitting emission factors, while allowing for flexible input of data, resulting in effortless emission factor mapping and data quality assurance. Autopilot is a context-aware suggestion engine, which uses natural language processing to interpret your data and recommend the most closely correlated emission factors to use based on your business activities. Autopilot specializes in providing emission factors suggestions for Scope 3.1 and 3.2 data and can process invoice data, material data, or similar inputs in a large scale. With just a few inputs within Excel, like a product description and an optional set of filters to narrow down the list with possible results, you'll get a list of suitable emission factors with your data, along with a data quality score. You can ask the Autopilot to search in specific emission factor sources, for example, like UK base or XIO base, to prioritize certain regions and year, and to only search for either spend, weight, or volume-based factors to ensure the results will be a fit for your input data. From a data quality perspective, every chosen emission factor will have an associated confidence score. This represents how closely correlated your product description or text input is to the recommended emission factor and is intended to provide data quality guidance to you as a user. This is determined by the level of data relatedness in the words and associations with your text input. As an example, if you have an item from Starbucks in your data, Autopilot will give emission factors for coffee. Similarly, if you put the word laptop, Autopilot will also be able to deduce that this is associated with computers and will also provide detailed emission factors around laptop types. This is where the context-aware element comes in. Let's look at the Autopilot usage options. We have two categories which are split into Suggest or one-shot estimation for utilizing the Autopilot. Let's look at Suggest first. Based on your input data, for example, industrial mill, the Autopilot Suggest will essentially return a list of suggested factors based off your input data and criteria for the sources. From here, you can select which emission factor is the best suited to your use case. Based off your selection, a calculation will be made with the chosen factor, which will output your carbon insights. Alternatively, if you want to simplify your Autopilot usage to a one-step process, you can utilize our one-shot estimation. For one shot, Autopilot will match, select, and calculate the results in one go. There's no need for you to select from the factors, just instant results. One shot will make the calculation using the factor with the highest similarity score for added accuracy. That's a crash course overview of how Autopilot operates. Let's jump into some practical examples and have a look at how this works. First, make sure to download the demo file from our website. As there are multiple ways to make use of the Autopilot via the API, we also offer different options via the Excel add-in. Let's start out by looking at the one-shot mappings, which are a great tool when you have very clear input data available and want to map large amounts of data. We start out by sharing the open text query, where we could essentially enter any product name or description. For example, if you purchase some steel, we can put this into the text field. We can then choose if the emission factors to be considered for the matching should be more manufacturing focused by typing manufacturing in the domain field, or if you're open to all emission factors in our database being considered, you can set the domain field to general. Let's set this to general, for example. Next, we define the amount of material purchased or used and the unit of the amount. So let's go with 100 kilograms of steel for this example. Finally, we can optionally specify the year and region for when and where we've purchased the goods. We can set this to 2024 and France. The autopilot will attempt to find an emission factor as close to this year as possible, but might not match the year entirely. Additionally, you can indicate whether the autopilot should search in other regions, if no factor can be found for the given region. Using the Climatiq.autopilot formula within Excel, the input data can then be inputted and a result is outputted. Let's dive into what the output means. We can clearly see the kilograms of CO2 equivalent, the emission factor name used, as well as the activity ID. You can copy and paste the activity ID into our Data Explorer to see more information about a selected emission factor. Along with this, as always, there's the source database used to make the calculation, the applicable year, region, and ID for internal usage, as well as the autopilot confidence score. You can also use the autopilot for spend-based emission estimations. For example, if all the data here was spend-based data in euros, we can simply change the unit. Observe how the new unit has been accounted for and how the outputs have changed accordingly. Now let's assume you might be dealing with more complex input data, for example, very detailed or ambiguous material names. In this case, the first match of the autopilot might not always be the most fitting factors. Here is where the suggest capability comes into play. In addition to the input query and existing filters, you can also specify the number of results to be shared and the sources in which the autopilot should search. Additionally, you don't need to specify the exact amount of goods for which you want to estimate the emissions. Instead, you can let the autopilot know that you're simply looking for spend-based, weight-based, and/or volume-based factors. However, all of these filters are optional. As we can see, the autopilot then shares a narrowed down table of emission factors that match our search term criteria. As covered earlier, confidence score represents the similarity between the search text and the emission factor selected, along with some further details. To then make use of these suggestions for an actual estimation calculation, you can simply copy the suggestion ID of the factor that you would like to use, scroll down to the table below, and paste it into the left column. From here, you can enter the amount and unit associated with the item you want to calculate for, and using the estimate suggest formula, you can make the final calculation, which will provide the CO2 equivalent estimation. Like the formulas we've talked about in previous videos, you can also use the autopilot formulas in your own Excel files to build custom setups that best fit your use case. Let's look into the last autopilot example, the extended version of the suggested flow. This brings together the capabilities of the suggest options with the scalability of the one-shot matching. In this demo sheet, a lot of data aggregation and processing is happening in the hide columns. So feel free to take a look if you're interested in learning more. You can just expand out the hidden columns. But for now, let's just dig into how you can work with it. As before, we can specify our input query and the list of filters. In the hidden sheets, the suggest formula will then retrieve the top 5 results for each entry and populate the suggestion selection with these factors. You can then select the factor that suits your use case best from the dropdown. As next steps, you can input the relevant amount, which will trigger the final emission estimation using your selected factor and the shared amount. To summarize, these are the 3 different methods for utilizing Climatiq's machine learning automated matching of emission factors to your business data. That's how to automate mapping based on your business activity data within seconds. To learn more about the different calculations you can make using Climatiq, please continue to the next videos in this Excel how-to series. I'll see you in the next video.